one of the things that we did was we recognized that in a circle, the two radii always form a isosceles triangle. Now, you get different types of isosceles triangles, but the radii are equal in size, and so the angles opposite of those sides will always be equal. So that was an important fact or idea that we came across in the last lesson. And then what happened was we had a look at this one. And so this was probably the biggest new thing from the last lesson, and that was that if you have an arc CD or a chord CD and you make an angle at the center, that angle will always be double the angle at the circumference. And so, for example, if I move C, you'll see that it changes. So the angle at the center changes, but so does the angle at the circumference. And so sometimes this is called the arrowhead theorem or the arrowhead fact. If we drag it across, it looks a little bit like a bow tie. And actually, you can go the whole way around, in which case it looks like that. But I'll show you another picture in a moment. We just want some awareness of that. And then let me show you this one. So this is just the shape slightly differently, where the arc that's being used is the major arc. It's this big one. And then so these two make the angle at the center. And then these two make the angle at the circumference. And it's almost like 101.4. If you double it, you get this one on the outside. So this is the main theorem. And then we also spoke about some terminology for circles. So I just want to go over those quickly. If we talk about a circle, we have the center of the circle. Then we have something like that, which is a chord. We can have something like this, where it just touches the circle at one point, which is a tangent. We can have something that goes through the middle of the circle, and that's called a diameter, if it goes from the one side of the circumference to the other. That's the diameter. What else did we talk about? So that's some of the stuff. Oh, we also spoke about something called a cyclic quad. And a cyclic quad is a quadrilateral where all four vertices land on the circumference of the circle. So we spoke about that being a cyclic quad. And then we also spoke about the curved line along the circumference, like between 2 points in the circumference. That's called an arc. And maybe we spoke about one or two more things, but that's the essential stuff. So give me a thumbs up if that is all looking familiar to you. Give me a thumbs down if you feel like, what is this man talking about? Okie dokie. Well, let's practice using these facts or theorems about circles and lines and shapes. I want to know, what is the size of the missing angle in this first multiple choice question? So if we think about this arc is the one that's, oh, we use the word subtending. So if we've got this arc over here, and we'll call the arc like XY, it subtends the angle X at the center and the one at the circumference. Well, double 42 is 84, and so the correct answer is 84. This is double the size of, yeah, perfect. Okay, well, let's have a look at these two. So what is going to be the value of X in the first one? And what is going to be the value of X in the second one? We'll call this number 1. We'll call this number 2. So that is going to be X is 50 degrees. I'll talk more to you. So the convention when answering these questions is always to give a reason. But for today, I just want to focus mainly on getting used to the shapes, and then we'll add the reasons as we go. All right. what about the second one? The second one's a bit tougher. So I'm going to give you some time, and you need to find me, using what we learned in the last lesson, what is the size of angle X down here? What do we think the size of angle X that is sitting down there is going to be? Okay, so this is where we have to be careful. I'll give you the arc that we, oh, this is way too thick. Let me get a more relaxed highlighter. So if you think of the arc AB, and it is going to make an angle or subtend an angle at the center, which is the green one. And then it's also going to subtend an angle at the circumference. Why don't I ask you this? What is the size of angle O1? Do you all see that the size of angle O1 is going to be 240 degrees? So if that one is 240, well, then the one down here has to be half of that, which is going to be 120. So the angle down here is in fact 120. Now, that might catch a few of you, so don't be too worried if it's just because of whether you're using the major arc or the minor arc. So for example, here, we are using this minor arc here, and we make the angle at the center. And then we also make the angle at the circumference. Can you see how we're using the small arc, whereas here we're using the bigger arc. All right, so let's carry on going. Now, I want us to try and find the value of X in this drawing. What do we think the value of X is going to be in this drawing? Okay. Ah, this is sneaky, hey? Okay, I'll give you a hint. So imagine the chord AB is the kind of base on which this is happening. And I'm going to make oh, that's way too big. Oopsie daisy. So let's start with the chord AB. And I'm going to make an angle at the center, which is going to be the blue one. And then I'm going to make an angle at the circumference. Notice how I'm still starting from the point A and B. So what do we think the value of X is going to be now, everyone? Would you like to have another go? It's amazing how a couple of colors are very helpful. I think the angle at the center has to be twice the size of the angle at the circumference. And since the angle at the circumference is 60, the angle at the center will be 120. So X will be 120. And the reason this catches students is because it's almost like it's bending over to the side. But if you think about it, there's AB, that's the chord on which everything is based. And we make an angle. It's like we're pointing our hands. We're like pointing to the corner, and then we point to the middle. And the one at the middle will always be bigger. Okay, no, I'm on 2.2 now. Yeah. Okay, so let's go across to 2.2. Now we're starting 2.2. Now for 2.2, I want to find what X is. Let's start with finding what X is. So what do we think the angle X is going to be? We know that the angle at the center is 150. Okay, so we've got this is the arc on which, so it's the arc AC that is sort of the base of the building block. But then we also have to get the angle X at the top, and that angle X at the top is at the circumference. So I'm going to say, well, I'm going to take 150, which is the angle at the center, and I'm going to halve it, and I should get 75 degrees for this X over here. Give me a thumbs up if you understand why X is 75. Give me a thumbs down if you don't. Let me see the thumbs. I can't see them thumbs. Digital thumbs, real thumbs, I don't mind. As long as I see some thumbs. Okay, fantastic. Okay, so you understand that. Now, the other one that we have to look at is down here. So how are we going to get that one? Well, I'll give you one sneaky tip. Why don't you work out what this angle over here is first? What do you think O2 is? Oh, I just took something out there, but anyway. What do you think the angle O2 is, which is on the other side? Like, where is it? Sitting here. I want to know what is the size of angle O2, which is sitting over here. I think if it's the whole way around is 360, then O2 will just be 210. But if that one is 210, what is Y going to be? So we've decided that must be 210 because 210 plus 150 gives me 360, which is the whole way around. But what is half of, well, okay, let me not give it away. What do you think Y is going to be then? So Nako, the reason is that we're using in this scenario, so let me actually get rid of this one. It's a bit like what we were doing earlier, where we are using the major arc. And if you imagine that I am going to the middle here, okay, then that would be 210. But then using the same one, I can actually go to here over here. And then the angle at the circumference is half of the 210, which is 105. That is a little bit tricky to see, but once we learn about cyclic quads, you'll also have an easier way to do that. So if you found this one a bit weird, don't stress. I don't mind if you find that a bit weird for now. It'll become easier the more we do it. Is it always 210? Well, Sanako, the fact that there was a 150 there already, it'll always be 360 if you go the whole way around. So if 150 is taken up that much, then what's left is just 360 minus 150. Yeah. Okay. Let us have a look at this one, these ones. Okay. Oh, flip, made it too big. Okay, I want to know what is the size of angle A in 8? What is the size of angle A in 8? So I look at the angle at the circumference, I'm going to double it, and I'm going to get 92. Okay, so you guys have kind of got that one. That's a bit boring. Let's find you something that's a bit more exciting. Okay, I want you to find me in this drawing. I first want you to find me what D is. And then after we found D, we'll try and find C. But first, tell me what you think D is going to be using what you've learned so far. give you one extra hint to help. And that is that the arc that I'm focusing on, or the chord that I'm focusing on, is the AB. And what I'm going to say is that this goes there, and this goes here. Can you see that the angle at the circumference is D? So what do we think D is going to be? Callan, I agree with you. Can anyone else see what Callan is saying? If the angle at the center is 88, the angle at the circumference is going to be 44. So D is going to be 44. Now, if that is 44, that's very helpful. So I can say D is 44, but what about the C sitting up here? Okay, I'll give you another hint. What is special about these two green squiggly sides? What is special about those two green squiggly sides? Who would like to put their hand up and maybe tell me they're feeling so comfortable to do so? They're equal. Indeed, Buchler, they are. Why are they equal? Callan agrees they are equal. Why are they equal is the question. Okay, the reason they are equal is they are radii. They're coming from the center of the circle. And so this side is equal to this. So really, I have an isosceles triangle that looks like this, where that is 88. What is the value of C going to be? If I know this is 88 and I know these two are equal, what is the value of C going to be? I just pulled it out over here. We can think back to the last lesson. What did we use to get that? So there's two of them. So there's going to be another C over here. But we know that 180 is equal to 88 plus 2C. And if we take away 88 from both sides, we will get 92 equals 2C. And if we divide both sides by 2, we will get C is 46. Give me a score out of 10 about how you felt about that question, where 10 is perfect understanding, 0 is nothing, 5 is a middle understanding. How are you feeling? That was a bit tougher, but that's part of the learning process. So I just want to see if yeah. Okay, so that was a bit tricky, that one. All right. So what we'll do is we'll do another one maybe that's similar to that, just to help us kind of find our feet. Let's do number 12. So can you find me the value of G? And then after you've done that, can you find me the value of H? Go ahead and do that now. And I'll give you a hint, the chord, oh, well, too big. The chord that I'm basing things on is the chord AB, or you could think of the arc AB as the base on which the angles you're going to make. So tell me, what do you think the size of G is? And then what do you think the size of H is? Who feels like they have some ideas? Okay, so, oh, sorry guys, I'm making things fly around a little bit. So I think the angle at the center is G. So that's the angle at the center, and the angle at the circumference is there. And so G must just be double whatever the angle at the circumference is, because let's just highlight this again. So there's G, and there is that. And so that is equal to 76. Give me a thumbs up or an 8 out of 10 or something if you got that. If you could see that G is 76. Now, if G, oh, okay, we're not happy. All right. Should I try this again? So, can you see this chord here? Or this arc here, AB? I'm going to make an angle at the center. A nice thick blue line here. And you'll see that the angle G is sitting inside of that. But then if I go from this AB and I go all the way to the top, you'll notice that I have the angle 38. So the yellow one must be double the 38, which is 76. Now, what you'll notice is that these two blue lines are radii. So we're going to do the same idea as what we did last time, where we say, look, we know that this angle and this angle are the same. They're both h's. So we're going to go 76 plus 2h equals 180. So going h plus 76 is 180, because this is a triangle. Then we will get that 2h is equal to 104, and then h is 52. Can anybody, does anybody have any questions or comments? Give me another score out of 10. If 0 is no understanding, 5 is the middle, 10 is perfect. How are you feeling about these questions? Then it helps me understand how fast I need to go, or how slow to go, basically. So for G, what did we use? We used the angle at the center is twice the angle at the circumference. So if you think about the angle at the circumference is 38, the one at the center is twice the size. Yeah, the sort of bow tie shape. Yes. Should I get rid of this quickly just so you can see it again? So you're going from AB and you go to here. There's the yellow. Okay. And then if you go to the top, there is the angle at the circumference. And there's a relationship between the green angle and the yellow angle over here. You can see the yellow angle is bigger than anyway, like that. Okay. All right. So let me try, see if I can find, or can I find any more like this? Let's have a look. Okay, we're going to carry on with this after the break. All right, don't stress too much. What you can do is you can re-watch this part, but those were slightly harder, but we're going to carry on now with a new fact about circles. And then after the break, we will continue with this idea. So I want to just show you what's called the angle in a semicircle before we have our halftime break. And the angle in the semicircle is another well-known fact about a circle. So if you look, you have a diameter, which is going through O. Look at what happens if I move the point along the circumference. What do you notice about the angle at the circumference? What do you notice about the angle at the circumference? So if you've got a diameter as the base and you are moving this around, it stays 90. Yes. Now that's a little bit weird, isn't it? Although, hold on a second, there's actually a good explanation for this. What is the size of the angle on a straight line? How big is this green angle that I'm saying here? How big is that angle at the straight line? How big is a straight line angle? A straight line angle is 180 degrees. But then if the straight line angle is 180, the angle at the center is a straight line angle. So it's 180. And what is half of 180? It's just 90. So that's why when you have a straight line through the center, a diameter, the angle at the center is 180, which means the angle at the circumference is 90. And so whenever you see a diameter subtending an angle at the circumference, it will be 90. And so this is another fact about this. So the first two lessons are all about the center of a circle and facts that go with it. Let's do a little multiple choice question. So it says, what is the size of angle P, which is sitting up here? And your choices are A, B, C, or D. I want you to try and decide which angle, what is the size of angle P? So angle P is this one up here. Hey? Be careful, it's this one up here. So from what I was saying earlier, this one up here should be 90. Right? This one over here should be 90 because it's the angle at the circumference. If you start from the diameter and you go all the way up here, then it will be 90, the same way the straight line angle over here will be 180. But what I do also know is there's an 18 hiding down here. So what is the size of angle P? Well, I go 180 minus 90 minus 18, and I'm going to get 72 degrees, which is D. So another new fact that you need to know about circles is that a diameter makes an angle at the circumference, which is 90. And we're going to carry on with that after the break. But you know my rules. You can't do more than half an hour of maths without a break. So let us turn on our cameras and let us stand up. I want to see everyone's happy faces, or even your not so happy faces. I don't mind, but I want to see everyone up. I don't want anyone sitting down because I know that this will make a difference to your learning. So we're going to start with some nice deep breaths, and we're going to go in. Breathe out. Breathe in. Breathe out. Breathe in. Breathe out. Okay, then let us put our arms out a little bit and let's do some circles. So we're going to do some rolling circles, and then we're going to change direction to go back. Okay, then what I want you to do is have your arms up, and I want you to twist from side to side. Okay, then let's do some tricep. Like this. And like this. Okay. Oh, my shoulders are tense. And then let's shake out our arms. So nice and floppy. Shake out this arm. Let's just let someone in. Let me shake out the legs. Shake out the legs. And then last up, let's move our bodies. Make sure you don't whack anything, so you're clear. And we're going to do 15 jumping jacks in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 10, 15. And that is that. Okay, so I hope that you are feeling like your brain has had a break. And then let's go to a Maths 24. Can you solve the Maths 24 puzzles for today? So if you haven't played Maths 24 before, all you need to do is make 24. Oh, my breath is still catching up. Oh. How do you make 24 using 2, 3, 3, and 6, using just the normal operations, and you have to use all of them, or 8, 3, 3, 2? Can you make 24 using those? Let's see. Okay. Who is going to be our Maths 24 champion for today? You can do it. Let the glory be yours. That is a 6, by the way. So I haven't done this one yet. Let's have a think. What would I do? Pilar and Callan have put some options in. Let's have a look. Callan says 3 times 3 times 2 plus 6, which is a correct answer. Or you can go 6 times 3 plus 2 times 3, which is indeed both of these options are correct. So Pilar and Callan, you are champions for the moment. Does anybody have anything for the blue one? Would you like to give it a crack? Okay. Well, then I tell you what, if anybody has it, they can pop it in the chat, but otherwise we're going to return to our circle geometry. So let's do this. Okay, so I told you about angles in a semicircle. Let's have a look at these 4 questions here. I want you to look at this thing, and I want to point out that this is a diameter. And I want you to tell me what is the value of angle A and what is the value of angle B as we look at these 4 circle geometry problems. You can, if you're feeling thing, you can pop it up, put it in the chat, whatever way you have of contributing. So Quena, Callan, Buchle, thank you very much. What do you think that A is? Well, I think that's the diameter, and I subtend an angle with the diameter. A must be 90. And now I also have a triangle inside of my circle. And so if that is 90 and that's 55, one way of doing it is just going 180 minus 90 minus 55, and that would be 35. Okay. So this was 90, and this one over here was 35. Okay, let us go down to C. Are we going to do question C now? And I'm going to slow down a little bit. And what we know here, I want to start with is what is the size of angle A in this drawing? What is the size of angle A? So pop your answers in the chats if you are. So you've got a diameter, which is here, it goes through the middle, and this makes an angle of 90 at the circumference. So, but there's already a 57 there, so you go 90 minus 57, and you will get 33. Okay, so that is 33. All right. What is going to be the size of angle B? What is going to be the size of angle B? Look carefully at the drawing and think about what you can use to help you find the size of angle B. Sanako, you are correct. It is also 33. Why, Sanako? Do you want to tell us? Pop your mic on. Just tell us or pop it in the chat. Why does it have to be 33 as well?
So, aren't A and B equal, sir? The size of A and B equal?
They are. Did you recognize that the sides were equal or the radii were involved?
So I noticed the size that I noticed that the sides were equal, sir.
Perfect. Okay. So you noticed that there were radii that were helping you out. And so that's why you knew this was 33.
Yes, sir.
While I've got you, do you think you could work out what E is? Which is this one over here. How would you find what E is?
So can't you say 180 minus 33 minus 33?
Yeah, because it's a triangle, so it has to. And then what would that give us? 120 minus 6. What's it going to be?
It's 114.
Perfect. Yep, 114. Thank you so much. That was great. All right, now someone else. Who wants to have a crack at finding D? Who feels like they could work out? Did I see Gundo's? Oh, whose hand did I see there? Oh, is it Bukle? Yeah, Bukle, what do you think it's going to be?
Those two sides, what is it? Those two sides are also equal, sir.
Oh, okay, but so you going for those two sides are equal, but so okay, are you going to try and do C first?
Yes, sir.
Okay,
So
what did you get for C?
C will also be 57.
Yep, and the reason is because these are both radii,
Yes.
and so these two angles have to be equal. Okay, perfect. And then for D, what did you get?
I got 66 because the sum of the interior angles is 57 plus 57, which gives us 114. And then that minus that is 66.
Yeah, I agree. So this is going to be 66. Sanako, I see your hand is up. Let's go to you. What is your question?
So I noticed, can't we say that D is equals to B because C is no D is double of B, sir.
Ooh, yes. Okay, so you've spotted another way. Okay, so
Yes.
Sanako spotted, it's the same answer, but what Sanako has spotted, and I'm probably gonna have to rub something out here just for you to see it, but if you look here and you think of this chord, you can subtend the angle here, and then you can also subtend the angle at the circumference. And you know this angle at the top here is 33. Oh, flip, sorry. So B was 33. What's double 33? It's going to be 66. And that's what D is. D is 66. So you could have also gone that route, which is exactly the same answer. Well done. That was good.
Thank you, sir.
Okay, let us look at D. Can you guys, I'm going to give you some time, see if you can find what A, B, C, E, and D are. See if you can figure out what those are using the facts that you know about circles. Where would you start? Put your answer in the chat. Tell us where would you start? I suppose these are angles on a straight line. So I'd probably start with B. B would be probably my favorite one to start with. So that would be 108. What would you go for next? I do see those two are radii, and so that could maybe be helpful. Bukle, what is your question?
So I wanted to know if I could maybe help with figuring it out.
Please do. What was your thinking from this point? So I assume you noticed the radius, eh?
I actually didn't start there. I started on the other triangle.
Okay, go for it. Yeah, please
So
do.
I said,
Yeah.
the sum of DC and 72 is 180. So I said 180 minus 72,
Okay,
which
so you
gives
went,
us
which gives us 108.
108 divided by 2, which gives
Okay,
us 54.
but you recognize that this one and this one are both radii.
Radii.
And
Yes,
so
sir.
that's why you can say 108 divided by 2 is 54. And in fact, D is 54 and C is 54 because those are base angles in an isosceles triangle. Okay, perfect. Yeah, I agree completely. So all you've
And
got
then
left to find now is A and B, A and E.
E.
Yeah.
So then we can see that the center, it subtends the circumference, if you can see there, which
Yeah.
means that A will also be equal to 36.
So A will be equal to 36. Okay, so
Because we say
you
72
basically,
divided by 2.
but oh, you using the angle at the center is twice the angle at the circumference. Okay, so you're absolutely correct. A will be 36. The other way you could have done it is you could have said 180 minus 108 divide by 2, and you would have got there as well.
Yes, sir.
And then I assume that E would also then be 36.
Yes, sir.
Okay, perfect. Everyone, give us a score out of 10 for how you're feeling about this type of question, where 10 is perfect, 5 is sort of okay-ish in the middle, 0 is nothing. Let's see the scores in the chat. And I can know then where I can go to next. And be honest so that I know kind of where you're standing, because I don't have body language to help me. Oh, okay. There's different types of reasons, and we're going to cover the reasons in future lessons. But some of the ideas we used here were like angle at center is twice angle at circumference. We spoke about this in the previous lesson, but that's the one. We also would be using the reason sum of angles in a triangle. So that would come up quite often. We could also use the reason radii when we have thing, or we could use angles opposite equal sides. And that would be kind of like D and C. They are angles opposite equal sides. So those are some of the reasons that we would use. Okay. So before we end today, I want to show you one last fact about circles in the center. Oh, it says it's not happy with me. What happened? Okay, well, I have to come back to it. Maybe I should show you this another way. So here's how it works. It says, if you have a circle and you have equal chords, so let's say I have a chord of that length over here and a chord of that length over there. How would I show that they are equal? I would make a line over there. Now, here's an interesting fact about circles. Equal chords subtend equal angles at the center. So how would that, oh, flip. Okay, let me just draw this again. Equal chords subtend equal angles at the center. So basically, as long as your chords are the same, they will make the same angle at the center. And so that's called equal chords, equal angles theorem. Equal chords will also, and I'll draw a second one, equal chords will also subtend equal angles at the circumference. So let's say I had these two and they were equal. If they make angles at the circumference, so let's say this one goes here and that one goes up here, then let's use a different symbol. Let's use a different dot, actually. Then equal chords subtend equal angles at the circumference. And so that is something which is another fact about circles in the center we want to start to think about. And I just want to finish with these two questions to just sort of let you get familiar with that. So what is going to be the size of angle X in 5.1? What is going to be the size of angle X in 5.1? You'll notice there's an equal chord. There's one and there's the other. They are equal chords and they are making, or they are subtending, an angle at the circumference over here, which is 24. And then they are subtending another angle at the circumference over here, which is 24. And based on what I just said to you, the X is going to be 24. Now, a similar example to this is if these are two equal chords and this subtends the angle and this one is this, what is going to be the size of X? Again, yeah, if the chords are equal, they're going to subtend angles at circumference that are equal, and X would be 56. Now, you might say, oh my goodness, how do you know all this? And there is something called proofs that we can use to help us prove that this is true. But for now, you're kind of taking it on my word. I was hoping to show you an example here if the browser was working, but it feels like the animation is not happy.